In this video, we will look at directly analyzing the memory by using WinDBG. There are two ways to use WinDBG. One is to utilize memory dumps, which can come from a crashed processes, or we can ask the operating system to create memory dumps for you. And the other case is that we can attach it as a debugger to diagnose the live cases. In the following demo, we will continue our analysis with respect to our adding a form around the checkout screen, and we will try to address the root cause. At this point, I'm ready to reproduce my problem again. I run. WinDBG is available from Windows Store, but also is a part of Windows 10 SDK. I go, attach the process, find my application, click attach. At this point of time, you may see optionally in this blue bar, some of the symbols are being loaded, and this may even take a few minutes. So if you see so, please be patient. The next thing I do is I need to load this SOS module. SOS is a helper to debug .NET and .NET Core on WinDBG. To load it. And the next thing I do is I instruct WinDBG to break on any .NET exception by typing S6ECLR. And I resume my debugger. I had to type multiple times of go G for continuing, and then I click placeholder, and as soon as I click place order, my debugger gave me a warning. If I want to see the exception details, I type PE after a bang. I can see the exception object by clicking there, but there's not much useful information. And if I want to see the call stack, I can type bang CLR stack, and I can see where this exception is being thrown. And as soon as I see the top item on the call stack, I saw a method that takes a string. So there must be a problematic URL, I presume. So the next thing I can do is to dump stack objects. So if I type bang DSO, it will show all objects that are in the current stack. If I go up, then this is the top of the stack. I go back. Now I see something interesting. I can see there is a URL called checkout question mark. Where did this come from? Apparently the root cause was, since I add a form field, it actually by default in HTML, form fields work in get mode, not post mode. Actually, the form I added caused the URL to be hit with a get method. As a result, there was a question mark operator. Apparently, with Blazor applications, this kind of forms are not much compatible, so perhaps I should have avoided using them from the first place. I was able to find out the root cause of my problem. Basically, adding a form tag would cause a get method, and it actually caused request with the checkout question mark that was an unhandled root for my application and caused the exception. There are many other items that we can do with WinDBG, such as inspecting memory, and you can switch between threads. If I want to see all the stack traces for all the threads, I can type star tilde star e CLR stack, which will print me all the stack traces for all the threads. Then I can see what my application is exactly doing. There's another way to use WinDBG. In this case, I have used as a debugger, live debugger. Please note that if you do this in production, your entire process will be blocked, so it may not be a good idea. The other alternative would be to use a memory dump. So you can instruct the operating system to get a memory dump, or you can right-click any process, and if you click create dump file, then you can open that dump file with WinDBG and you can make offline analysis, just like the way I did before. And this is the end for all our sections. I hope you enjoyed and learned few things. I enjoyed sharing all my knowledge with you, and happy developing!